mostly just doing a quick audio check before I start doing anything major. Otherwise, welcome to this quick little seminar, quick little activity. What we'll be doing, if you weren't otherwise already informed and aware, is we'll be doing a bit of a quick dive into one of the major lessons, domain modules of the Certified Ethical Hacker certification, specifically system hacking. The general layout that I plan to go through, as we're kind of running through some of the first trials of this, is we'll be starting with general introduction of some major terms. What is system hacking? Moving into some practical and practical examples, moving into some specific examples of techniques, tools, things of that nature, and then we actually have some labs to show from the actual certified ethical hacker itself to actually show a visual demonstration of some of the things we'll actually be talking about in short. Right. So seems like otherwise the closed captioning caught me all just fine. Let me know if anything otherwise is the case. But if that's all well and good, I don't see any reason why we can't transition over them. But yeah, the way I at least suspect this should all go, unless there's some kind of otherwise major hamperance to what we're doing, is we'll spend about the first hour or so just looking at our looking at slides, talking about topics and things of that nature, and then we'll spend the rest of the time talking, or at least showing more of the practical stuff, the labs, as it were. And again, in terms of this being geared towards the actual certified ethical hacker exam, we'll be using the same labs you would have access to if you were to take that cert. So first and foremost, this is me, myself, just to get that out of the way. My name is Marcus Clark. I work for Training Camp primarily, if not pretty much entirely. I write their material. I help to instruct their actual courses, and now we're doing these quick dives into the certs and topics themselves. So I help to write this kind of material as well. Right? Name a cert that most people generally want. I pretty much have it, but we need to spend more time actually talking about content, less about me. But there's the basics of me if you need it. So, and you'll get that'll become a lot more relevant if and when you choose to actually take one of our courses, if and when you choose that this cert or any other seems like what you want. So, anyway, giving as much time as possible to the actual content, especially since we actually want to go see those labs, right? So, first and foremost, this is one of, and I would generally say probably the biggest when it comes down to it, section of the certified ethical hacking exam that is system hacking. What's actually important to initially define is, what do they mean by that? What does it mean by system hacking? To get that, I first need a basic understanding of what's called the cyber kill chain. The cyber kill chain is a model that assumes that all attacks have a standard order of procedure, regardless of the unique targets, situations, and motivations of any individual attacker. All attacks need to go through standard phases to commit pretty much any means of compromise. Like, for example, number one is reconnaissance, information gathering. You really can't do anything unless you have information about the target you are trying to hit and stuff of that nature. Now, system hacking itself focuses on, I'd say, about the four middle steps or the four middle phases of the cyber kill chain. That is weaponization. Weaponization is based on the information about targets you have gotten up until this point, choosing an appropriate payload like a malware, as well as what vulnerabilities are you going to leverage in order to make use of your malware, of your payload. Delivery, pretty straightforward, is finding and choosing a method of getting this payload to your target, which can be involved. Usually that's something that in classes where we spend a little bit more time diluting these topics, there's a very large variety of different ways that the same malware can be delivered. And on top of that, there are many different vulnerabilities that a single payload can actually be used to leverage. So there ends up being a lot of flexibility in terms of, it kind of emphasizes why delivery is its own phase. Right? Exploitation, which is actually the point of, the actual hacking bit. As I like to say very often in the actual classes, this is that I'm in moment, right? This is also frequently referred to as the point of initial exploitation, as I have it typed there, because this represents your initial access. Right? What follows that is goes by a couple of different names. Command and control is common in the kill chain, but also persistence or gaining a foothold. What is most important once you get that initial access, because we're talking about this in brief, but it can take quite a lot of effort and time to get your first machine access. You want to make sure that you have a hard time getting taken out of that system. You want to establish persistence, a foothold, right? You want to make sure that you are well established where you got, so it's easier to get back in the future, but also make it so that you are less detectable and harder to remove by whoever's trying to stop you. So this slide just kind of goes into, if you were to take those four standardized kill chain phases and break them down a little bit more, this also generally covers the main topics we'll be hitting in this quick seminar, this quick coverage of this topic. So gaining access, escalating privileges, executing applications, hiding files, and otherwise covering tracks. This kind of actually covers at least the two main labs that I want to show you from the iLabs. Kind of actually does demonstrations of each of these. Hiding files a little bit less so, but we'll talk about it if nothing else, right? And the goals, frankly, being pretty self-explanatory. Anything else I would generally add to what each of these phases has in terms of nuance, I'll make sure that we actually cover it when we have something visual visual to follow up with, right? There's a very important tool called Metasploit that we'll be using as a primary means of actually demonstrating a lot of these different things in brief, but still, right? Otherwise, techniques/exploits used, again, what you see over there on that side, or at least in that column, that's mostly going to be things that I'm going to be defining here during this lecture period. What's a rootkit? What are the common types and approaches to password cracking? Primarily focusing on password cracking with the time that we have, because once you start getting into the specifics of individual vulnerabilities, then that's a conversation that can go for, well, kind of endlessly. There's an immense amount of vulnerabilities that exist per operating system, per device type, per target, per payload. So we'll be mostly just honing in on what you can generally assume is the most common reason that initial access tends to succeed or tends to happen, and that's credential theft or exposure. Right? By far, not the only means to gain access to a system. Some of the demonstrations I'll show you actually don't necessarily use credentials, but credential theft tends to be one of the most common, if not the most common, for various reasons. So one of the first specific concepts that kind of is attributed to any compromise, regardless of context, is called privilege escalation. Privilege escalation can be understood as simply as gaining access to something that is otherwise restricted and you shouldn't normally have access to, unauthorized, right? It is subdivided into horizontal and vertical. Horizontal escalation, up and left and right across, right? Horizontal escalation is gaining access to someone else's confidential or otherwise private information or data. This type of privilege escalation doesn't actually involve ha- accessing something necessarily above you or forcing escalation of an account you have. That ends up being, if we were actually to switch gears in terms of this is how you would read this in the standardized test of the CEH. Horizontal escalation does not necessarily involve forcing a higher permission of the account that you have access to. This is just accessing someone else's account or device. Vertical, take the account that you actually already have, let's say your standard work account, and then using some exploit to force your account to have a higher level of access than it should. So vertical escalation doesn't necessarily involve someone else's account. It's making yours higher, right? Vertical, up and down, going up, actually escalating when it comes down to it. Otherwise, horizontal is gaining access to someone else's stuff, someone else's account, right? But yeah, when it comes to privilege escalation is done in many different ways, a lot of which aren't even necessarily technically inclined whatsoever. If I were to, for example, walk up to somebody's computer that they didn't lock during lunchtime, that's horizontal privilege escalation. Now, that being said, we'll be showing some tools and examples of vulnerabilities that can be leveraged that allow for privilege escalation, or sometimes just built-in mechanisms of a device that allow for the same thing. Right? Other key components, concepts, and components to, well, especially system hacking, that is, weaponization, delivery, and especially initial access, are the backdoors and Trojans. Backdoor is a more broad term that refers to any kind of exploit, malware, vulnerability, or anything like that that allows an attacker to bypass normal security mechanisms in order to more easily gain access to target systems and content. This can be, again, a built-in feature of an OS. This can be an application that has an unknown vulnerability. This could be a malware that an attacker initially installed and is allowing easier access. Any of the above. It's a broad term. Trojans are very frequently associated with being backdoors, though they don't always have to be. Not all of them are, but a large amount of them are. Trojans, otherwise, most people have a baseline understanding of what a Trojan is, right? It's a malware that settles itself up with. It comes packaged with something that is seemingly legitimate, or the best ones will give you something legitimate. And when you run it, something malicious is hiding as a background process, unknowns to the user, right? Anybody that has, well, if you have any experience or knowledge with, the standard pirating of most software, a lot of these pirated softwares come with a key generator program. This key generator will 100% give you access to that software, but then there's a malicious program running in the background that you don't notice, that you don't see, right? So programs that are used to make Trojans are frequently referred to as wrappers, which is why I always prefer to use the phrasing, the terminology of packaged with. Trojans are packaged with something that is disguised or seemingly legitimate because the programs wrap them together as a bundle. While we more than likely don't have time to fit in the Trojan lab into the short time that we have, the EC Council labs do actually have a very basic one that works very well called Elite Wrap that can pretty much spit out Trojans in a matter of 5 minutes or less, depending on you have what you actually need to do it. But they're pretty accessible programs and easy to use, all things considered. A rat is pretty much the type of Trojan that is associated with being a backdoor, as well as other things. But its primary job as a remote access Trojan is all the things about Trojan, but to establish and maintain remote connection methods to the infected device. Rats typically also being associated with remote control of the devices they're infecting, causing them to turn into what are called bots very commonly. Right? Remote access Trojans are also associated with things like botnets and distributed denial of services. But outside of that, what they're very well known for, like I said, I'd say the most important thing that they're doing, which contributes to turning things into bots and botnets, is this establishment and maintaining of persistent connections. Both backdoors and Trojans and rats being examples of them are heavily or if not incredibly necessary for persistence when it comes down to it. And again, considering the reason that persistence being as important as it is because it can and it often does take a lot of effort to establish initial access. You need to guarantee you install agents like Trojans, rats, and whatnot, so that if you happen to need to step away or you need to disconnect or for any other reason, you have easier methods of getting back. The attacker has a guaranteed means of accessing you, as long as the rat's still there and functioning. Moving to somewhat different topic, concept. Passive and active attacks, you'll see described quite a lot when mentioning different methods of all sorts. They're pretty generic terms. Anything referred to as passive involves methods of typically information gathering. Where I get the information, or the attacker gets the information that they would want from a source other than directly the target themselves. So I learn about your device without communicating directly or connecting directly with your device. The term sniffing, also called eavesdropping, is associated with a lot of, if not most, passive techniques. Right? Sniffing involves having a device or program monitor network traffic. Right? I'm learning about your device, your target device, by looking at the communications it's having with other devices on the network. That is what sniffers do, network traffic analysis, network traffic analyzers. They're, again, generally considered passive because eavesdropping because you happen to be on the same network isn't the same thing as a direct connection to the target to get information. On-path attacks are frequently associated with passive reconnaissance, passive sniffing as well, because on-path attacks, also historically known as man-in-the-middle attacks, involve attackers being able to intercept target user traffic, target device traffic. This involves the attacker somehow. There are several different means of which somehow the attacker has gotten into a position where they can intercept any traffic you send out to a particular destination or device. This often involves the man in the middle, the on-path attacker, spoofing a legitimate device like a router. If I can trick your device into thinking I'm a legitimate router, you will naturally send internet-bound traffic to me. Thusly, the interception happens that way. Replay attacks are a common attack associated with man-in-the-middle exploitation, where you're pretty much as close to literally as possible. You are intercepting user traffic, you're copying it, and then you're sending it some other period. These replay attacks are very frequently associated with attempts to access or log into other people's accounts by essentially replaying credentials as a means of what might be also called session hijacking. Yeah, replay attacks, when it comes down to in simplest terms possible, is I'm already eavesdropping or observing your traffic. I take a copy of it, and then I send it again for some means. There are a couple of different things you can accomplish with it. Now, in terms of sniffing, the actual activity of packet and interception and analysis, a very, very well-known tool, one of which is actually very well demonstrated in EC Council's labs, is called Wireshark. Wireshark is also known as a protocol analyzer, which is technically made up of two different functionalities or devices. A sniffer, the part of this that is actually viewing, intercepting other network traffic, and the actual analyzer, the protocol analyzer part of the protocol analyzer, is actually showing and interpreting those packets in a way that's human readable and useful in various ways. So this screenshot being literally a screenshot directly from Wireshark. Any packet it intercepts, it tells you the IP addresses, it tells you the timestamps, it tells you the protocol, and based on that protocol, you get the additional information you see on the bottom and on the right. Like what we have here highlighted is a DNS packet. So you would see things like what type of DNS record is this packet, DNS query information related to this packet and the DNS server. So learning about devices based on how they communicate with other devices is the general premise of network traffic or packet analysis. Wireshark does this very well. It does require, like anything that you would refer to as a passive or especially sniffing as an activity period, it does require that your device or the device attempting to do it is sitting in a part of the network where it can actually eavesdrop in the first place. Like if I'm trying to eavesdrop or I'm trying to sniff traffic remotely, like across the internet, that's a different challenge than if I was a local machine trying to sniff. Local machines, a device that's already on the same network as you, has to do very little to actually start running things like Wireshark. So it matters a lot what the attacker's perspective is, where the attacker is starting from, or I suppose, where the attacker has already gotten to. But active attacks, on the other hand, inversely, is any method that involves connecting to or simply communicating directly with your target for different means, gaining information as a response from your target, or to connect and issue commands or upload malware or anything that involves actual interaction. Right? Password crackers are often referred to as active when they connect to a target network and try to find passwords in real time. Not all password crackers are active. Some password crackers don't have the ability to find passwords, just reverse engineer them. Those are the ones you would also refer to as passive. They don't crack passwords by finding them, they crack passwords because you gave them one. Thusly, they're more passive. So this also includes this also includes a variety of tools, very capable tools referred to as exploitation frameworks. Exploitation frameworks are a lot of different things. One of the most well-known is referred to as Metasploit, and being the biggest focus of the lab's demonstrations that I'm going to show you during this little short period we have, it does everything from running other tools like scanning tools, reconnaissance tools. Its primary job, however, is to select, create, deliver, and even do post activities for exploits. These exploitation frameworks, at least nowadays especially, have become kind of a one-stop shop of pretty much all the main activities we're talking about during the course of this lecture we're doing here. That is system hacking. That is the weaponization, the selection and creation of malware and payloads, the delivery methods, which it's fully capable of, the actual access based on those deliveries, those exploits, and then Metasploit has a lot of tools for post. What is called post exploitation is simply things that happen after you deliver and connect. And we'll see a couple of examples of things we can do there. I'm going to, depending on the time we end up having at that juncture, I'm going to actually go through a couple of different common activities you would do once you get that initial connection successfully, and just show you different kinds of things you could do once you're there, post exploitation. Two other types of malware payloads that are often associated with at least the before initial access. That is, a large part of information gathering, password and credential theft are keyloggers and spyware. These are another two very common designations, categories of malware that most people are familiar with at face value. Keyloggers, recording typed input of devices. Though there do exist different types of keyloggers, and absolutely in real life, more advanced keyloggers that can record more than just your keyboard input. But the default is assumed to be just your keyboard inputs. What keyloggers are actually subcategorized by is where they are hidden, where they get installed, and or what type of device they're meant to infect. Like mobile device keyloggers are considered their own category. They have to be packaged, they have to function a bit differently. Otherwise, spyware, these are usually collections of, well, these are malware suites, because their goal is to collect and to otherwise deliver private information of people, of infected devices, to the malicious actor. These tend to make use of other tools like keyloggers, like remote access Trojans are very often associated with them, but they use many forms of recording methods in order to, well, accomplish this goal. Fileless malware is another a broad category of payloads, which are not payloads in the same traditional sense. Unlike traditional malware, fileless malware, quite literally, does not involve uploading, delivering a file as malware. Fileless malware otherwise is any exploit, any payload that takes the form of something like remotely executed code, remote command execution. So forcing a target device to run some kind of script or instruction on the attacker's behalf. That doesn't involve an actual file, that's just remotely executing code. Or making use of applications, programs, installed content that is already on the victim's machine. A really important concept for many different reasons is called living off the land, which falls under this. Living off the land is using any existing software in order to compromise your target and accomplish your goals. Like, for example, one that I'll circle back to it in a handful of slides, is Windows Task Scheduler is a really good example, right? What's a pretty straightforward way of establishing persistence on a system you've already breached? Use the built-in task scheduler of the OS. Why go through the effort and all of the headache of trying to upload this custom suspicious malware when I could just use a program that the OS already trusts? And that's what makes living off the land so incredibly useful, right? It is always going to generally be better, if not more sneaky, to rely on programs that the user and the device already inherently trust or don't see as problematic to accomplish the same goals. Buffer overflows are another good example of this, where based on certain application vulnerabilities, this application vulnerability would allow you to actually inject code directly into RAM, which would then be executed as a form of remote code or arbitrary code execution, as it's sometimes called. So different means of doing something similar, right? It doesn't really quite matter the means by which you inject code and get the device to run. The idea is that we are injecting code into this device and making it run it as a form of instruction. Buffer overflows do this in memory, in RAM. Yep. That's a basic intro to a couple of handful of topics, going into a little bit more specific with this techniques and tools. Again, I'd say a vast majority of what I'll be focusing and emphasizing with the lab demonstrations is going to be based on the stuff that we're seeing here. So, password cracking techniques. As I said earlier, while there are a lot of things that fall under the wheelhouse of the means by which an attacker gains access to your device, by far the most common is theft, exposure, and cracking of credentials. So that's a big focus. So we got some options. First and foremost, based on operating system or protocol, that ends up being the first thing we need to identify as part of reconnaissance, right? In Windows, we have a database called SAM. SAM in Windows, both Windows authentication systems, but also just Windows local devices, is where credentials are stored in Windows. So a lot of password crackers, or what are going to be called in a moment, dump utilities, want to retrieve credentials from here in order to then crack them or use them otherwise. Right? NTLM and Kerberos are protocols associated with credentials. So other than knowing that a standard operating system stores credentials in a particular location, knowing what protocols on a network are known to be associated with credentials lends to valid targets as well. As opposed to looking for a stored location on a desktop, you are looking to intercept network packets and protocols that you know may handle or carry credentials. So that's what you're looking for when you identify protocols like NTLM, like Kerberos. Linux, on the other hand, has its own stored locations, etc password being where user account information is stored, etc shadow being where password hashes are stored themselves. Again, just demonstrating, based on operating system, knowing your targets lends to different information that you would obtain. Knowing things like in most Linux deployments, we have two different locations for different sets of credentials technically, account information differing from the actual passwords themselves. In a similar way that tools would seek to extract content from the SAM database, we have tools that would seek to extract the same credential-based content from the etc password and shadow locations. So what are at least the kind of the common approaches to doing this that are most frequently associated with password cracking when it comes down to it? We have brute force. Brute force is the most straightforward means of password-based cracking compromise. It's telling a program to try exhaustively every combination of character it can possibly do in whatever amount of time it has in order to try and eventually stumble upon the correct password. This involves an excessive amount of password checking attempts. So it's known for being really slow, very inefficient, is what it's going to be often referred to as. If a brute force attack is going to be successful in a reasonable amount of time, it tends to require a large amount of computing power, really strong processor, really, or multiple machines working on it to be considered anywhere close to, a time efficient, if nothing else. Dictionary attacks and rainbow tables are very similar in premise for password-based attacks. A distinction that I personally like to make, one, because it fits the test that people are gearing up for when they look at this content, but also it lends to a better understanding, in my opinion, is brute force and dictionary attacks are what I will traditionally refer to as password cracking. Rainbow tables are what are often referred to as a collision attack. It involves passwords and retrieving a component of them, but it doesn't result in the same thing. So a dictionary attack is a pre-made list, is a pre-made list of words, phrases, and possibly passwords that you put into something like a text file. It can be as simple as that as well. For example, go to Google, Google the 100 most common passwords, copy and paste that into a text file, and you essentially have a basic word list. When you do a dictionary attack on whatever password cracker of choice you choose to use, it will ask you what word list or lists you would like to use. This is then simply the password cracker tries every word on your list. If one of those words on the list is the password on the user's account, it does not take a machine a very long time to parse a list of text, right? So this is known as being very efficient, very fast, because machines can run through this list pretty quickly. Right? Rainbow tables are similar, but instead of a pre-made list of words and phrases, rainbow tables are a pre-made list of hashes, which is what passwords get stored as. On the actual backend databases, SAM as well as Etsy Shadow, you don't see the plain text. That is, the password as the user would type it. You see the hashed output. Your passwords are put through an algorithm and stored in an unreadable format for security and for various other reasons. So rainbow tables is a pre-made list of these hash values. But otherwise, like a dictionary attack, the program tries everything on your list and tries to find a match to confirm, well, what the thing we're looking for. Now, again, rainbow tables I refer differently as a collision attack because when a rainbow table succeeds, you don't get the password as the user knew it. You get this unreadable hash value. If a dictionary attack or a brute force succeeds, you see a readable password, a human typed known password. So again, distinction between what are frequently referred to as the cracking attacks, because they actually reverse engineer or tell you what the actual password is. And then rainbow tables belong into a category called collision attacks because they show you hashes, which can either be used to crack. You can take a hash and then try to do something like a brute force to it, or hashes can just be useful in and of themselves. Getting a hash is not necessarily a loss whatsoever. Right? Otherwise, in terms of what kind of options we have for tools that accomplish this, there's a very large variety. Despite the fact that the main three methods of password or hash retrieval are pretty straightforward, all things considered, a lot of different tools have different nuances to them for accomplishing these. Some of these tools are more geared towards a type of device, like wireless password crackers. If you've ever heard of a popular collection of tools called AirCrack, AirCrack is very well known for being geared towards Wi-Fi based cracking and things like that, right? OffCrack, Rainbow Crack being specifically used for rainbow tables. Rainbow tables are usually handled by rainbow table dedicated utilities just because of the way that it has to do what it does, right? You often see. And other than using password crackers that crack passwords that you either supply them or they find, we also have utilities that can extract passwords directly from where they're stored. Some well-known examples would be PWDump, which literally stands for password dump 7. Mimikatz is also a very well-known one. Or exploitation frameworks can typically have essentially add-ons, plugins that allow for password extraction alongside everything else that they tend to do. One of the what is called a module, one of the extensions of Metasploit that I'll actually be demonstrating, given that we get all the way down that list, is actually going to be one of the password dump utilities built into Metasploit. And then otherwise, some common names for active, also called online password crackers, the kinds that can actually connect to a target network and then find passwords in order to crack in real time. Hydra and Medusa, you'll see everywhere. You take a certification exam, you see, most people talk about password cracking. These are two common ones that show up. John the Ripper being a good passive attack cracker. I'll mention him again when I show him to you in the given lab. But yeah, Hydra and Medusa, very good at not just online password cracking, but also very good at simultaneous password cracking for multiple users at once and things of that nature. when it comes down to certain different categories of password cracking utilities, it is sometimes it comes down to preference. Sometimes interfaces are better. Something like Kane that I had there, full name Kane Enable, has a lot of other password related utilities built into it. It's not just a password cracker. It can also do network sniffing and stuff like that. So different tools have some advantages over others. A lot of times it's good to just use multiple tools to give yourself more variety. And attackers often do. Right? Different means of doing the same thing is not a bad thing when it comes to retrieving information or trying to steal credentials, because all these devices register differently, they perform slightly differently, and sometimes that's all the attacker needs. Right? So lockouts do present a pretty straightforward remediation for these attacks, however. Right? Brute forces being as well brute forcey and inefficient as they are, even dictionary attacks being much more organized are not immune to lockout. Dictionary attacks, in order to be fast, they need to try every word on a word list. A typical word list is made up of millions of words and phrases. If your lockout policy is 3 attempts and then you're done, that makes the dictionary pretty much, the same amount of time and efficient as a brute force. So there are plenty of ways to unfortunately do that. A common technique referred to as a password spray is a good thing to focus on. Honestly, the best thing to emphasize here. Password spray. So normally, and actually part of my baseline definition of the other two, when you're doing a brute force or a dictionary attack, you are focusing all of your attempts on a single account because that's how you make them as time efficient as possible. If you have 500 phrases on your word list, you try all 500 on the same account. Password sprays, being aware of lockout, let's say your password lockout policy is 2 attempts. Oh, no, two. That's uncommon. Three attempts, which is pretty standard. And then you have to wait 10 minutes, right? The password spray will try 2 attempts on a bunch of different users, right? Instead of triggering lockout, you just move to the next user and then try the two or maybe the exact same 2 passwords. You wait for the password attempt reset to happen, and then you go back to the first user on your list and you try a different 2 sets of passwords. Now, in terms of, monitoring your network or just trying to keep track or find attacks like this, it's still a pretty easy pattern to determine, but the attacker is at least not raising a more obvious alarm of lockout. And if nothing else, even if it's obvious, it might trigger an alarm. The password spray allows them to continue trying as opposed to being, completely stopped by lockout. So there's at least that. That's at least valid for why an attacker would do it. Buffer overflows. So I mentioned this in brief as well. I don't have too much to add here, but they're seen as a pretty common, at least accessible means of accessing or injecting some kind of script or command into a target device by means of a vulnerable application. So application vulnerabilities are very nuanced and diverse. There's a lot of application vulnerabilities that are specific to a type of application, like web application vulnerabilities. Buffer overflows are pretty much any application, especially those that are written in the C programming language, are notoriously vulnerable to this. But yeah, because of the fact that any application running on a device has its script and code being interpreted or processed within RAM, this is using a vulnerable application to forcefully inject malicious code into that same RAM space, referred to as the memory buffer. If I can get code to be injected directly into RAM, the idea is that RAM would run it because it can interpret it, and then the bad thing happens. The actual effect that this would have can be is varied, depending on what the actual script is asking to do. So, in terms of, after choosing, let's say, weaponization, things of that nature, we eventually need to work down to what are our actual methods and means of connectivity. How do we actually get access to and connect to target devices? Also has a couple of different options. Though, some common methods, we have SSH, Netcat. Both of these tools are very similar because actually Netcat was designed to mimic SSH's functionality, but be more flexible for the purposes of compromise and, assessment, really. But SSH being your standard network administration protocol and tool, its job is to allow a remote connection to a device in order to issue administrative commands to that device. Now, SSH is known for being secure, right? It has encryption for anything being sent through it. It also utilizes credential-based requests, so you can't just connect to a device without having the proper credentials. However, just because a protocol is known for being generally secure doesn't mean an attacker can't make use of it, right? If an attacker manages to successfully steal or password crack an administrative credential, they can use SSH the same exact way that an admin would. If an attacker gets access to SSH, now the attacker has a way of sending encrypted malware and disseminate that across your network, and that's hugely problematic, right? Another reason why password cracking specifically ends up being such a big focus is, somebody like an admin loses their credentials. It's the most significant thing you can kind of suffer from in most contexts. Now, Netcat, again, designed to work very similarly, if not pretty much designed to be an alternative to SSH, but for the means of compromise. So it's more flexible and it's not as restrictive. It doesn't require a password. It doesn't utilize encryption because its job is to, well, just connect to a device and issue commands to it. Right. So yeah, Netcat, of the two, obviously SSH being a case of living off the land. If an attacker can gain access to it, then it's what you should use. It's normal. It's a normal administrative tool, so it's going to be more trustworthy. So there's that. But also, it's very powerful, being what it is. Netcat is going to be something you can download from the internet. It's openly accessible from the get-go, but it requires the attacker to open up the target device through some other means. We're not going to exactly use Netcat in the labs that I have loaded up for the time we have, but the concept is going to be similar to what I'm going to show you. I'll at least, based on the specific use of Metasploit that I'm going to demonstrate to you, I'll describe. I'll point out and describe where there are similar facets to what a tool like Netcat would do. But otherwise, other than these two, which are, SSH being a good example of living off the land and Netcat being a good example of a tool that most attackers are going to use in any other case, right? Any remote access tool or protocol is valid here. VNC, which is virtual desktop implementations, especially for virtual machines. Windows RDP is frequently targeted and utilized. Pretty much any means of remotely accessing, viewing, controlling, or otherwise interacting with a device can potentially be leveraged here. These are just some of the most common, especially considering that the main thing that Netcat relies on is successfully delivering it and running it in a target device. All the others require, well, credential theft or some other kind of access to the target device or a vulnerable application. It depends on what you have available to you. Okay. So WinRM and PSExec. So post-exploitation, right? Once I've established my initial connection through whatever means and whatever tool, we have a whole lot of different options for doing something on this device. That is issuing further commands to it and or executing, modifying, or accessing content within the connected device. So WinRM is an incredibly useful tool that allows for, to say it in shortest terms possible, configuration, access, and viewing of Windows OS content configurations and settings. A good number of post-exploitation examples I'm going to show you is using WinRM after I use Metasploit to actually get the first connection. But yeah, this is good example of living off the land at its best, because this is just kind of a one-stop shop for, hey, what's the OS doing or how's it set up? Attacker uses that, they know everything they'll want to know about your device for the most part. PSExec, remote execution, is really important. Not just WinRM can help me look at all of this configuration, setting, and device information of the machine, but I also need to actually run things, perform actions, remotely executing things. Tools like PSExec and WinRM as well can answer the question of, how does one get a remote device that you don't have full control over yet to run something on your behalf? These are some examples. Though these are a little bit more direct. There's a variety of ways to get a victim to doing this, but these are examples of how one might actually accomplish remote execution. Either living off the land or PSExec being a tool you would have to upload or find, but both are valid options. Before I switch over to the labs, last little section, or at least concept to generally overview, is persistence. There's one other section I have after all that, and that's general remediations for remediations for at least the base concepts we've been covering, but we'll save that after we get to the lab demonstrations all in all. So again, creating a foothold, establishing persistence, or sometimes called command and control, at least foothold and persistence are pretty self-evident for what these activities are. Again, once you get that initial access, you want to make sure that it's hard to, well, remove your attack, remove your connection, and if your connection is disrupted, if the attacker gets disconnected, you want there to be a means of more easily connecting in the future. That is also persistence, right? Rats are a very good way of doing this. Using netcat to establish remote connectivity, but also being able to repeat netcat's functionality, even if the attacker isn't there, is really important for persistence, and are all common activities. But also monitoring user behavior over time to learn more information, to possibly breach further or commit better or more substantial compromises. Rootkits are a common type of malware that are frequently and importantly associated with persistence. Rootkits are any malware, as most categories of malware are not mutually exclusive whatsoever. Rootkits are a type of malware that are defined by the kinds of places they try to install themselves in. Rootkits attempt to install themselves in system, kernel, or parts of the device, that is OS or firmware, that are deeper than what the user typically interacts with. The deeper in a device or an OS or firmware that you can install something like this, two major things. Generally, the harder it is to detect or find, both from the user level, and more basic security scanners might not be able to look that deep in a device, in an OS or firmware. And two, the malware or the malicious agent has more control and influence based on how deep it's able to install. I'd say two of the more substantial types of rootkits we have out there are kernel level and firmware. Kernel level being, the deep levels of the operating system, program software. Firmware being even deeper than the operating system. If you've ever heard of a common type of virus called a boot sector virus, that's a good example of a firmware level malware, right? It's installed itself as part of the startup process of your machine, meaning that that's the kind of malware that infects you before Windows even has a chance to begin, right? Even if you have OS level security, this thing is sitting underneath that, meaning that it could potentially bypass them entirely. And they're ideal for establishing persistence for those reasons as well, right? Being that they're inherently more hidden and harder to scan for means that they're more likely to stay undetected over time, so they're persistent. And two, the kinds of control you get by installing yourself, especially as kernel, allows you to modify and control things like startup processes of a target device. If I make it so that every time your machine starts up, it runs some kind of remote access script, that's persistence, and that's a great means of persistence. So covering tracks is also a pretty central concept to system hacking, specifically post exploitation, or once I've gotten my foothold and things of that nature. What is going to be important outside of just keeping a persistent connection? That is, well, hiding yourself. Attackers don't want to be found 9 times out of 10. So what are some, at least, approaches they use in order to accomplish this? In brief, of course. So first and foremost, I have 4 techniques that are pretty much the same premise, more or less. These techniques are used more for more subtle intrusion and exfiltration. That is, hiding the communication that the attacker is trying to send to and from systems. Tunneling being the primary premise here. Tunneling is a common network packet function where a type of network packet is encapsulated inside of another one. So let's say, you have a standard web packet, a standard HTTP packet, but you don't want that HTTP packet to look like an HTTP packet. You can use programs, software, network utilities to take an HTTP packet and shove it inside of another protocol, like let's say DNS, right? That is the concept of tunneling or encapsulation, right? For example, DNS tunneling actually being one of the most popular, the most frequently utilized, is taking some kind of otherwise potentially malicious, suspicious, or just anything, any kind of packet, and shoving it inside of a DNS protocol. To any device that is looking, inspecting, analyzing this packet, it looks like a DNS packet. It doesn't look like what the original packet inside of it was. There are absolutely security implementations that can look deeper, and those are the things you would want to mitigate this kind of thing. But the premise here is that you encapsulate, you tunnel using protocols that you know your target either can't or won't prevent. Why DNS tunneling ends up being the popular method, the go-to, the most popular? DNS is a necessary internet protocol. If your target is blocking DNS entirely, not allowing DNS or anything like that, they're not using the internet. DNS has to be enabled, and bonus, firewalls don't necessarily know how to inspect DNS. They have they don't have the ability to understand what DNS is, so that additionally helps your malware bypass them, right? Because the packet looks like a DNS packet because you've encapsulated in one. So that's the stealth method here. This is covering tracks in that, like I said, if your victim were to look at logs of previous packet activity, they may see a DNS packet, and that's not necessarily an immediate alarm. DNS is common because it's necessary. Otherwise, the concept of a reverse shell is one that I'll actively be demonstrating, especially with Metasploit. But a reverse shell, in brief, I'm definitely paraphrasing here, is a means by which the attacker somehow gets the target device to request a connection to the attacker's machine, as opposed to vice versa, as opposed to the attacker's machine requesting access to a internal device. Because just as a general, rhetorical, sensible question, what's more likely to be seen as suspicious, right? A random internet device requesting a connection to your PC, or your computer requesting access to a random internet site. One of those is a standard thing that happens all the time. My device talks out to the internet all the time. Your device is always communicating to random unknown internet devices and servers. So if an attacker can trick your machine into requesting a connection outward, that's less likely to throw up alarms based on the type of system. So the difference between the different reverse shell methods is what kind of protocol you're using to do this. So there's variety in how you would do this. HTTP being common, ICMP being a way to do it. We're going to use it integrated into a tool like Metasploit, but it's the exact same concept. More specifically, we're going to be using a reverse TCP shell, which uses some form of TCP protocol. Right? Another big topic, at least across the CEH, but just in general, when it comes to covering your tracks, is clearing and modifying logs and any kind of event history. Because as per what their job on paper and literally is, logs and event viewers record histories of events that have occurred within applications, within operating systems, and within networks. So we need to do a couple of things. We need to disable them or modify them or change them in order for attackers to keep themselves hidden. So one, we have a living off the land example. Windows Event Viewer makes it nice and easy and straightforward to do this. We can just go in Event Viewer, modify, change, delete logs, assuming the correct permissions. To note, as a asterisk to a lot of things I've covered so far, a lot of these things, in order to actually perform, attackers will more than likely need to privilege escalate in order to get the permissions to do some of these actions, especially when it comes to modifying certain kinds of logs. Absolutely. Other than using the living off the land, the existing event viewer, there are also a lot of scripts for Windows in the form of PowerShell. PowerShell being a Windows exclusive automation scripting language. PowerShell has made essentially pre-made utilities for accessing and modifying logs already. One that's very well known is literally called clear event viewer log.bat, which is an automated process. Given the time, I'd say it's an insanely quick lab because all it essentially requires is me to double click clear event viewer.bat, and it shows itself clearing a bunch of logs because that's what it does. Meterpreter is one we'll actually be demonstrating directly. Meterpreter is actually a component, an extension of Metasploit. It's technically considered its own utility, but it's used in it's a part of the default installation package of Metasploit. So think of Metasploit as as a library that contains a bunch of tools that work with that library. This library is a library of exploits, malware, and vulnerabilities. Meterpreter is the thing that's actually establishing and maintaining connections that Metasploit is trying to, well, identify and deliver for. So Meterpreter is, well, the connection handler, the session handler. Right? It maintains and also allows for delivery of things through its established connection. Again, I'll show you this explicitly. But yeah, as a means of clearing logs, pre-made and pre-configured tools like Metasploit and Meterpreter have built-in utilities explicitly for doing activities like this. Hell, Meterpreter has a built-in utility for escalating privileges that I'll also show you that pretty much involves me typing about 4 things, hitting enter, and then if it works, it just works. We'll go through the process of that. Depending on what operating system you have, like with PowerShell, Linux and Unix, Bash has some very straightforward commands that is for clearing, modifying logs. Export history 0 completely turns off logs from that point forward. Or if you want to be more subtle, like let's say the attacker wants to not just have no history of activity, because that in and of itself is suspicious, right? That might trigger an alarm itself. We may try to be more subtle and modify timestamps and logs to maybe pass the blame off to another device, mislead investigators and incident response to give yourself more time to react. Because again, there definitely is a drawback to being too overt. Like there's definitely a good reason why attacker will not erase all logs entirely, because that might raise the alarm even faster, right? Misleading is always going to be preferred when it can be accomplished well. Right. Another example, other than either using built-in scripting languages or utilities, we also have ones that you can, well, download. And there's a lot of these. Audit Poll is one of them. This is still another example of a Windows utility, which does also help to highlight just how diverse living off the land as a concept is, because, oh boy, there are things that are associated with Windows that can be used just for the intended effect. The same lab where I, again, given the availability of time, that I might quickly run event viewer clear.bat also has a quick use of audit poll, which is more or less issuing 2 or 3 commands and then watching it alter logs. Right? Generally, as long as you know what logs you're looking for and how you want to modify them, as long as you have access to these utilities, it's not hard. It's more a matter of how does the attacker want to modify these to give themselves as much time as possible, right? Otherwise, your schedulers, amazing, excellent, and simple means of establishing persistence without installing any additional anything. Windows Task Scheduler, because Windows isn't known for having unique or crazy name conventions, and then cron for Linux, Unix-based systems, right? But yeah, both of them allow me to schedule some kind of task automatically based on a time interval or based on some kind of event trigger. Like if you're familiar with the concept of a login script, you can essentially set those up here. Every time victim.user logs into their desktop, you have a script run. So an event trigger being a common means of, running one of these, right? Both have, their different utilities when it comes down to it. Task Scheduler is more straightforward and user-friendly, being Windows. Tron is a little bit more obtuse, being as it's Linux and you have to learn the syntax, but something that is an example of a consideration of the nuance of OS-based utilities like this. Being aware that in cron, any job that you make will run as the user you are currently logged in as. So as an attacker, that is really important as a perspective, because that means that if you have only gained access to a low-level user account, you can only schedule tasks at that lower level. You can't necessarily expect to use cron to run an admin task if you're not already an admin. Something that's actually unfortunate, but a good example of the nuance between OSs, which there is many. An older version of Windows Task Scheduler, I believe, Windows Task Scheduler 2.0 in particular, was known for having a vulnerability where, regardless of who you were logged in as, you could schedule a task at any level. So if you are a low-level user, you could schedule a task as an admin, which was bad for hopefully obvious reasons. But that's a vulnerability from and a good example of living off the land. Both a built-in tool is already useful, but also has an additional vulnerability that makes it even worse than it already is. Right. Some other evasion techniques, because again, other than evasion through hiding the presence of malware activity within a device that's already infected. Like rootkits are really good at doing this. One of the first, the other side of being subtle is hiding your communication as well, right? I first referred to this when talking about tunneling and encapsulation, but there are many other methods for evading things like intrusion detection systems, filters, and things of that nature. These are two of, well, what ends up being a lot. But session splicing being a common enough method, this is taking what is prospectively or supposedly going to be your malicious packet and fragmenting it excessively, chopping it up into smaller and smaller and smaller pieces, hoping that filtration inspection devices can't piece together the whole malware correctly. Now, without doing anything else, this isn't going to be enough. Any kind of modern scanner or monitoring system is pretty capable of reconstructing fragments in the correct order. So session splicing will be combined with manually slowing down packets, sending packets at weird intervals, or sending redundant packets. So you take a bunch of fragments and then you do something weird with how they're delivered to additionally trick how the detection system can accurately reconstruct them. There's a couple of different methods just within this. Obfuscation, otherwise, is a broader term that generally means to make something less obvious, or generally to make something look like other than what it is, while still pretty much being the same thing. A good example of this, a simple example of this, is your good old decoder ring puzzles on things like the back of old cereal boxes and stuff like that, right? Replacing every A with a C, every C becomes a D, every D becomes a 2 or something like that. That's a simple replacement cipher, as it's called. That's obfuscation. You're still looking at the same message, but there's this a simple layer of something making it look otherwise. Steganography, as a pretty well-known concept, is a good example of this. Unicode, any kind of encoding, is a good example of this, right? Or something else that's also very well known by most people, even if you aren't actively aware of it. When and if you ever use your web browser, you look up at the URL, you notice very commonly a lot of special characters like /, are replaced with a bunch of what looks like nonsense, like %23C represents a /, %3E represents a backslash, or something like that. That's encoding. The general premise here with obfuscation, kind of regardless of the specific method you're using, is you translate your payload, you translate your packet into a format, into a different presentation that the scanner or security device might not recognize, but the target does. This is like, for example, if you decided to speak a different language in front of someone so that they didn't know what you were saying, but you're still saying the same words, it's just in a format that the person being scrutinizing doesn't understand, but the person you're talking to does. So, as a premise, as an analogy, again, obfuscation covers a lot of different particular methods. So, at this juncture, based on the fact that we're at the halfway point, all things considered, the last thing I have in these slides is countermeasures, remediation, which all in all goes quick. So I don't have too many things to hard emphasize here, but we'll be going through them. But I want to prioritize those labs, those demonstrations of some of the things we've seen, and also just to give you a look at EC Council's iLabs, which does come with anytime you take one of their certifications, they give you about 6 months access to the things, and they are useful. If nothing else, they contain a lot of tools and good instructions, really, when it comes down to it, for using at least a lot of the more key focus tools. But less of me talking about it, we'll actually get to it. For now, let's take a 10. Let's take about a 10-minute break, come back to that while you're taking the 10. I'm going to be loading up these labs, and we'll switch over to that and see what those are like. And then again, once we are through at least the key activities I want to demonstrate here for you, we'll go over this quick countermeasure section, and well, then that'll be at for at least that part of the content. So anyway, let's go ahead and do that without further ado. Switch you over to this quick little break screen for the time being. I'm going to put a little timer up here for you, just so you have a general idea, gist of when we're coming back. And yeah, I'll run you through these lab exercises for a bit, and I'll see where that takes us. Otherwise, I'll see you in a little bit. Okay, that's about, yeah, that was about a break. So let's get back to it, transition over and show you a couple of things. Ideally, yeah, like 3 labs minimum, but more if we can. Just squeeze it. So I switch back over here and here are Windows swap. So, like I was saying, while getting these things up here, and the specifically the lab environments that we're using here are the same ones that you get access to when you sign up for a certified ethical hacker from EC Council. So this is a standard lab environment. Um, Other than having activities and instructions geared towards the test itself, they also have just additional tools that actually don't end up being part of the standard CEH certification and are just there to kind of play around with and are just extra if and when you have the time to mess around with them and try other things. So they're generally pretty nice in that. Right? At least I like them for for some of those reasons, but just resizing a little bit here for you. Right, there we go. That looks fine and dandy. Great. So anyway, like what I was talking about in the the premise of the very beginning of this, the labs we're looking at are specifically from their module 6, that is system hacking. First one I'm going to look at is gain access to a system. More specifically, this is a quick look at the basic password retrieval and cracking. At least one method, though. You notice that there's a lot of activities here. I'm also going to stick to the first and then move on to the second lab to cover as many bases as we can in terms of content. So again, with CEH's labs, the instructions are actually pretty nice and clear. They actually give you quick links to the different virtual machines so that you don't necessarily have to, fuss around and navigate stuff like that. But yeah, did a little preset up here. So I'm going to be skipping a couple of different steps just to, you know, get to the actual demonstration itself. Right. So first thing I'm generally going to do is actually a type of tool that wasn't mentioned in the brief that we went over is this tool called Responder. Responder is a tool that is used to monitor for certain types of network traffic. Specifically, Responder is known for having a wide variety of protocols that it is aware of that are associated with credentials of various sorts. So once you start up Responder, like I did just here, it's a tool that pretty much is meant to sit in what's called listening mode. Notice that it just says listening for events. Everything that you see up here is essentially what type of protocol it's configured to listen out for. And there's a bunch. We only have a handful here, some of which are going to be related to what we're about to do. So that's all you generally need to do. Note, a point of clarification here. This attacker's machine in this simulated environment is already a part of the same network as the victim machine we're monitoring for, which is why it can see these network packets. It has to be in that perspective. It has to be in the right location. So switching back over to our victim machine, we're going to run a simple process that should communicate one of the types of protocols that Responder is looking out for. Specifically, this is an attempt to run or access a shared network location, a shared network drive associated with protocols like SMB, NetBIOS, and stuff like that. You notice here a credential pop-up came up. A credential pop-up came up. I'm going to put in, I don't know, let's just put in what I know this virtual machine's credentials are. Whether or not it works doesn't really much matter to me. Didn't work, but that's fine. Just generating some network activity for our monitor to actually pick up on, just in case the basic thing didn't already work. But anyway, failed attempt or not, we can then switch back over to the parent security and notice that there's some activity immediately, right? Any activity for the network or device that you have this thing set up to look for that is that is associated with or is a protocol that Responder knows and can look for, it'll otherwise display activity here, and it may do a couple of other things like poisoning, which isn't part of the brief that we went over. The CEH examination in its entirety goes over poisoning attacks itself. In short, poisoning attacks are often used as a method for setting yourself up as a man in the middle, an on-path attack, but we're not going there. But what I do see here is, for the user I just was in, Jason, this is a captured credential, specifically. This is a hash that I'm looking at here. It says Jason, the OS that he's working off of, and the longer part of this is a hash, Right? Hashes again are essentially a cryptographic version of a user's password that are stored in databases and things like that. Right. So at this point, you take the hash, the entirety of it. I believe again, as part of my pre-setup, I already have a file here named pluma.txt. You essentially copy and paste this file into a something like a text editor, and then well, you tell a tool like John. I'm going to use John here. A full name, John the Ripper. John the Ripper is a very well-known offline password cracker. What that means, as opposed to the active, the online ones, for offline password crackers to crack something, they need to be given something to crack. So some other method must be used to find or retrieve a password. You upload it into something like a text file, and then you ask John to go. That's really it. Otherwise, John the Ripper uses basic methods like brute forcing, dictionaries, if you have a word list configured with it. So while basic, it does still use the standard common methods, and then it just runs, right? The password of the user that I just intercepted for was the actual password itself was QWERTY, QWERTY. So respectively, it shouldn't take too long for it to figure this one out, but it's going to at least start with brute force. Seeing as it's starting with brute force, it's going to take some amount of time, period. So note again, it's not instant, but something you can actually do real quick is if you hit enter while it's going, you can see where it is in its permutations. So note it says H, now it's an N, now it's an R, so forth, so on. And it just keeps trying. Again, brute force is trying any combination of all letters of all lengths of everything until it happens to stumble upon the stumble upon the password. But because there's a word list actually loaded in here, this is getting intermixed with certain, well, things that would be on that word list. Right. So since the demonstration isn't actually to necessarily, well, show you the results, since we're essentially waiting for paint to dry here, that's the premise of, responder honestly was a better thing to demonstrate, right? A kind of tool that can pretty handily, without much effort other than turning on look for this protocol, can just find something like a hash. At this point, it's a matter of waiting, especially considering QWERTY is a simple password. John the Ripper is fully capable of that. Again, in another example, if I wanted a single tool that would do both, I would use something like Hydra, Medusa, or Cain and Abel, which can both detect and monitor traffic, retrieve a hash, and then crack it once it has gotten it. That's an active password cracker as they are defined. So I'm otherwise going to stop that session aborted. Again, if it actually succeeded, it would mention some kind of success. And they do also create a password list. They'll save any results it finds to its list. That's standard John. Right? Moving on, where we get a lot of the meat and potatoes, so to speak, of the things I want to show you, is actually Lab 2's exercises, specifically exercises 1 and 2, which take a little bit more time because it says privilege escalation, but it demonstrates far more than just that. We're going to be using Metasploit and some other common tools like it in order to actually show gaining access as well as privilege escalation. So for this one, again, did some pre-setup. You notice there's a bunch of things on this desktop already, but I'm going to first and foremost enter another terminal. Make sure that we're actually operating under root privileges, because to do a lot of these activities, we need to be a root user in order to access stuff like that. So the first thing here, I'm going to zoom in on this because this is a lot to type and it would just take time I don't feel like wasting on syntax. So there's this tool here they're having us use called MSF Venom. This is a payload generator, actually. What MSF Venom's entire job is to create, modify, alter, tweak malware. So what you're actually seeing here is this whole command, which again, I did some pre-setup and then I've typed this in already. I've had it generated. The result of which is actually here. You notice that the command ends with exploit.exe. I have a little thing here on my desktop called exploit.exe. That's the payload that is generated by this command. Most of what you're seeing here is the syntax, the actual command part of it, is configurations. So for example, you notice that it says Windows reverse TCP. So this is a Windows-based exploit designed, it's designed for Windows, and it's a reverse shell exploit, meaning it's a remote access malware. Platform Windows, you notice x86 is the deployment, the bit version. There are different format options you can generally pick, like where you see -F. even if this exploit was originally designed for Windows, which is where you see after it says P, you can actually tweak the format with other options in a payload generator. So that's what the part that says Shikata Ganai down there. That's actually something that's used to reformat or encode things differently, or add things like encryption. Actually, other options you're seeing this L host, you'll see this a couple times during these next two labs. That's how you designate an IP address of usually the attacker's machine, because what is the point of a reverse shell? I'm tricking a victim's machine into requesting a connection to my attacker's device. So what this payload is specifically doing, if a victim runs exploit.exe, the victim's machine will request connections to my attacker's device. So the big question ends up being, how do I get this to the target, and how do I get the target to run it? But otherwise, MSF Venom generates payloads very handily and pretty easily. Because of tools like MSF Venom and Metasploit, the explicit need for attackers to understand how to write script and code has been diminished. Not entirely eliminated. It's still an important skill for advanced attacks, but the fact that you can type something in like this and just get a payload right there on your desktop is pretty substantial. Right. So anyway, that's your exploit.exe. So just discussing it, because this is other background prep I did to speed this along, is a common method to distribute malware like this is through browsers and vulnerable web pages. So what this lab had us do is create a shared location on this Linux device, specifically www.html, because what we are going to then do is start up a web server application, a web server service on this device. Specifically, we're going to use a common one for Linux called Apache 2 start. Very basic command. This essentially runs a web server on this device, right? A web server is running here. Now that I have a web server running, I'm going to use it to host a file, because essentially the place that I uploaded a copy of my exploit to is the default file path for this web server service as it uses it. I can use this to essentially host this as a file on the internet, or at least accessible on the internet. Before we specifically get our victim to do that, we need to start Metasploit. So msf console is the basic start Metasploit command, right? Which takes a bit to load, because if you remember my general description of Metasploit, it's a library that contains many different tools for various different ends. So it contains a bunch of different known exploits, a bunch of different payloads. Hell, the MSF Venom command we ran, or at least I showed you, the MSF Venom directly works inside of Metasploit. The reason that MSF Venom is actually aware of this thing right here is called a module. This specific payload is within the Metasploit library. So it's actually pulling that from the Metasploit library. And this lab has you use MSF Venom outside of Metasploit, but a lot of common use cases, you'll load up Metasploit and run MSF Venom inside of this environment, because you generally get more utility out of that, but it can work outside. So otherwise, we're going to go through the relatively straightforward process of, okay, seeing as I already made an exploit, and assuming you know what that exploit is because you chose it for a reason, right? We need to essentially load into the tool within Metasploit to use the exploit. An exploit handler is what this would be called, right? And then obviously making sure that you spell the word multi right is important there, because I guess word of warning, if and when you ever sign up for and you use these EC Council labs, the Linux machine does not work well with copy and paste. So typing out some of these longer commands is a chore. Just a heads up, which is why I did some of this pre-prep. But anyway, yeah. So the first thing we generally did is Metasploit. What I want to use right now is I want to start setting up an exploit, a means of connection. Because again, Metasploit has a couple of different things. It has scanners in it. A lot of different kinds of scanners are the primary other kind of tool you'll generally see. But when you want to use an exploit, you use something like this. So once you say that, you tell it, okay, what exploit payload are you trying to use here? And then we tell it the same module, the same payload that we generated with the payload generator, right? You want to make sure that matches up, because otherwise it doesn't make any sense, right? There's Meterpreter as well. So this is also going to be the session or the connection handler will also be demonstrated here. Reverse underscore TCP. Had to watch for typing because typing and talking at the same time is not particularly a good strength of mine. So there, Meterpreter or MSF Venom, this is the specific exploit that I want to set up for. Now, it'll be demonstrated better than the other ones. So for most exploits, like I said previously, and especially since again we saw that with we saw it with MSF Venom already, something you'll generally need to set up, especially for a reverse shell, is the attacker's device. This is address. So this is the address of this attacker machine. Because again, the purpose of a reverse shell is to trick the victim into connecting to us. So that's the address that needs to be defined by this malware. So that's the L host, also called listening host. Who's listening out for a connection? The attacker is listening for a connection. The victim is requesting it. And then this is just a couple of other parameters that are necessary for this exploit to do what it does, essentially starting it. So note, started reverse TCP handler on that address. This is me, and a port that was part of the default settings of this malware. So my attacker's machine is now listening and waiting for someone to click, run, download this malware that I just made. So another thing that I pre-set up is, well, we can just kind of do it real quick. It's fine. So essentially, in terms of how does one get malware to a victim machine? You could pick your poison at this point. Phishing emails, malicious website that looks like a real one, social engineering, a malicious text message, you name it. The sky is open to you really when it comes down to this. But in this case, we started up a web server on a web server service, and we specifically have it in the location called share. There you go. So it worked fine, just right. So there's the exploit.exe that I've already copied in my pre-setup. So again, imagine this being looks like a legitimate website, and the user's tricked into downloading this. They download it, yada, yada, yada. And then, this error message that everyone and their mother ignores when they see it on their home personal machine, we're just going to hit run because we know what we're doing. All users are flawless in their execution of things that they do. And then it seems like nothing happens, right? You can go here. You don't see anything obvious. No windows have been made up. This is a background process. But the thing that the attacker wanted you to do has been accomplished. We can verify that going back to our parent machine, and note it now says Meterpreter session has been opened on a 1.11 machine, because by clicking that exploit, the victim's device requested a connection to this machine who is waiting for one. So 1.11 is the victim that I was just playing as, and that's the port they connected out to, and there's all the information we already knew because that's what we were waiting for. So Meterpreter, again, like I said, is the session handler. Meterpreter's job is to establish and maintain connections to devices that Metasploit manages to, well, accomplishes this for. So what I'm doing here is I'm saying, what I'm saying here is a sessions is, hey, there should be, since there's only one device I currently have a session for, I'm saying, hey, can you open up this particular Meterpreter session? So you can have many devices on hook right now. This allows me to say, hey, can I open up the session for that first machine or the second one or the third one? So this is session one, right? Once you're loaded in a Meterpreter, you can now directly send commands to interact with the device that this connection is with. So for example, basic information. Let's assume I know nothing about the device that I just compromised. Basic information. Okay, so this is a Windows 11 machine. The user account is Jason. Fine, fair. All right, cool, great. Right. Though this lab has me actually do this for another user, but it's all good. Right. So let me actually switch over real quick because I have this better set up on another user device, because another thing that it would have us do is, well, Meterpreter session representing an active shell to this device, we can do things like upload malware. So this actually answers another question of, okay, so if I got a victim to download this backdoor, this remote connection exploit, and run it, that's how I got this Meterpreter session. Can I use this to upload additional malware? Note, on this other device, I already have this exploit running, so we're just going to run this. Right? Anyway, there we go. But anyway, so yeah, An additional thing that we want to do is use this established connection to upload more malware because, well, it's not because we have a easier way of doing that now. One way you generally do that is Meterpreter has built-in means of doing this. So upload. Meterpreter just has commands in and of itself. So these are commands that are separate from the CLI of the target Windows machine. Meterpreter just has built-in commands to do stuff like this. So I'm just going to go ahead and do it. Should work just the same anyway. So in the attacker folder on the desktop, there should be a folder called broot, which is a tool I'm going to use for privilege escalation. So this is the actual privilege escalation part of privilege escalation. To clarify, this is a very specific executable that is used for privilege escalation, but it's an example of privilege escalation nonetheless. And then it's successfully uploaded, right? I don't have to use social engineering and a whole website connection anymore. I just have a straightforward way of uploading stuff. So that's what we did, right? Shell allows me to, as opposed to using the Meterpreter from this machine to issue commands remotely, Shell allows me to essentially access the command prompt of the device directly. So issuing things through this shell is as if I was running it from the device itself. Notice it turned into a Windows file path there. So this is me directly interacting with the shell of that device. So anything that I would want to do from the perspective of this device, you would use this for. So specifically, I would do broot.exe as they're saying here, assuming that's all that. And then it does a whole bunch of stuff. Again, to clarify, broot is the actual script that handles privilege escalation. And note that it's trying a bunch of different stuff. A lot of automated privilege escalation scripts try to run through many different forms of privilege escalation checks and then attempts. That's generally what's going on here. Right? Yada yada yada. So if I wanted to get back to Meterpreter, assuming running a privilege escalation script on the device itself was enough, you would then possibly circle back to Meterpreter to do other things. Like, let's say now that permissions may be opened up, I might try to upload additional malware or run commands that require that initial, that greater access, that greater access. So again, I'm going to upload something else. Home, attacker. This is what, generally what we do as a follow-up activity. So the broot thing, the privilege escalation executable that I uploaded and ran will often be referred to as a stager because that's, well, what it's doing. It's setting the stage for doing other things and, well, uploading additional things like the seatbelt utility. Again, now that the file is located on the target device, I'm going to run it from the target device. And specifically with this, I'm going to run the executable and then issue a command directly in the same line. This is more reconnaissance is what it comes down to. So a lot of information about the target system, not necessarily towards privilege escalation, but just in general. Hey, this is kind of just a readout of pretty much any OS level setting, permission, and restriction that can be pulled from this device using this utility. And there's a lot here. Notice that some of what is in here are other basic CLI commands like, oh, this looks like netstat. So it actually is this is what might be called a chained exploit. It's a script that chains together a bunch of reconnaissance things and activities you would want to do in one go, right? This utility in particular, seatbelt, also has different settings for what perspective you want to retrieve this information from. So, for example, the one I just did was for the system as a whole, but you could also set it to particular user groups or individual users, depending on what you're trying to get information about in particular. Right? Last one they generally have us do is seatbelt miscellaneous. So this one isn't necessary given that we've seen primarily what is going on. And I'm not trying to demonstrate the seatbelt script so much as Metasploit here, but group dash equals miscellaneous. But yeah, tools and utilities like seatbelt here and things of that nature would also be used in other activities we mentioned before, like modifying logs and log entries. Where seatbelt is mostly just doing reconnaissance and showing a bunch of useful information, you would instead use a script or utility for accessing and modifying logs. Or hell, since I can load directly into the shell of this device, I can just find where PowerShell is and run that clear event viewer script. Or using the shell, I can just run Windows Task Scheduler and things of that nature in order to perform similar actions, right? I'm otherwise just going to clear that so we can move on. One thing I will do is show an attempt at accessing one of those dump utilities, right? Something you can do once you gain access to a device that's really helpful is, oh, if this is a device that has a bunch of passwords, let's say we learn that this is an authentication system, maybe I can pull the SAM file, the SAM database from this Windows machine. That's what this smart dump utility in Metasploit potentially tries to do. However, accessing SAM requires admin permissions. So it says that we failed. This is intentional. Also, again, if you ever get to do these labs yourself in your class, be aware that some of the exercises intentionally show you a failure and then show you, okay, this is why we need privilege escalation. So what I would follow up with is, okay, what are the current permissions I have? I can't do that. Well, git system allows you to is a built-in command that allow you to upgrade permissions, but go figure, we're not allowed to do that either, right? Failed, right? We're not allowed to do certain things like that. Right? So operation failed. All right. Seeing as the methods available to me on the existing system aren't working, I'm going to actually back out. You can background a connection, essentially, literally putting it on the background. And we're going to use another exploit that also exists in Metasploit because Metasploit is an entire library of all sorts of exploits. The one we used was a remote access exploit. This is an exploit useful for devices that you have already accessed. So this one is literally called bypass user account control underscore FOD helper. This is a privilege escalation exploit also inside of Metasploit as a very good follow-up. So as just a quick example of Metasploit being very self-intuitive, let's say that you're using an exploit for the first time and you haven't done your research. I don't know why, but let's say you don't know. You know that these exploit packages have settings they need. How do you know what those settings are? Show options. Always missing an S. Always. These are all the parameters that this exploit needs for you to set up. So that's not even a mystery. These, why they're called modules, are very much pre-packaged exploits in a easily referenced library that is Metasploit. And then they even tell you, hey, these are the things you need to set up. If it's required, it says yes. And that's either something that you need to set, or note that some of these already have current settings because these labs are pre-set up. So these are already things that have been input in here. So they're required, but you don't need to set them. Session, however, it's blank. So that's what we're going to do real quick. So this is specifically the Meterpreter session because this is a follow-up exploit. So we know we only have one session and we know it's Meterpreter session 1. So we set that. If this was the second connection, we would set 2. Right? And then again, now we need to follow that up. Excuse me. Now that we've configured the exploit, our next step will be set and configure a payload. So we're essentially doing the same thing we did before, but we're delivering a payload, a reverse TCP connection, for more specifically, so that we can deliver this privilege escalation exploit, which is the actual thing we're trying to do. So this is using an exploit to deliver another exploit. We're delivering 2 payloads here. The one payload is to just set up a connection, this guy. And then the actual bypass UAC is the thing I'm actually trying to do. Again, show options. Even though we've already set this one up, so we know that we need an L host, we need an L port, which is already there, so we don't need to do anything with this one. Which means, well, since they're already set, because I've done this already, you literally just type the word exploit at that point. You just tell it to go. Setting up reverse TCP handler, because we are literally already backgrounding a connection, we've already done the reverse handler successfully. It just then says, oh, it's already here. We're going to just do this next part, which is the UAC bypass, which it seems like it didn't have a problem with. Basically, the setting continues, yada, 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 cleaning up. Session 2 is open, another session was open, sure, why not? But it doesn't seem like it ran into any issues. So that's fine, right? At this stage, well, as it says it right there, it's like, well, now let's check to see if things change. So get UID. All right, so we're still Windows 11 JSON. Just because I escalated, I used a exploit that allows me to escalate privileges, essentially. So we haven't quite done it yet. So if the user account restrictions have actually been removed, I should be able to use this get system command this time to elevate privileges. Again, this built-in command to elevate privileges. And note that it doesn't say failed this time. So let's do a get UID to check the current status and user. NT authority / system instead. So now I'm a system level account, which is higher than admin permissions, by the way, meaning I can do whatever the hell I want on this account now that I have vertically up and down. I vertically escalated the existing JSON account to something much more significant, right? So there's that. So that would be the privilege escalation. What can you do at this point is, well, anything that you wanted to do in the first place. So remember, I was trying to dump the content of the credential database. So let's try to do that again. Smart underscore hash dump. And again, this is a built-in utility of Metasploit for gathering the contents of the SAN database. You can also just at this point run a local program to do the same thing, like pwdump7 would be an executable that does this, but you let that run. It has no problem getting access to keys, decrypting everything because it's now a system level account, which accesses all things. And now you look at the content of a credential database in Windows. I see user accounts, I see their user ID number, their account ID number, and I see hash values of each. You can then copy and paste this into a word list, give it to Jason, and you let Jason crack these while you go and see a movie. Right? So there's that. And, again, for the same reason I cut the Jason lab short, I'm not going to run all of these through them, but that would be, the follow-up. I now have a list of hashes. These hashes can just be used as is, or you can run them through a password cracker like John the Ripper and let them crack over time, or both. Yep. So there's that. The next lab has us do a lot of similar things. So I'm not going to exit out of Metasploit here. I'm not going to create this backdoor. So they have you create a backdoor.exe, which is the exact same thing as the exploit.exe. They just changed the name. So this is another exploit that allows for remote connectivity if a user clicks on it. So we're just going to say we got there already. And we have the advantage of having a system level account. So we can just save time. So we're already past this. We've already got the user to download our backdoor. They clicked it. We came back here and we saw that an interpreter session was opened up. That's where we are. This is where we can pick up. So more examples of post exploitation. So yeah, sysinfo. This is just basic reconnaissance to start working up to somebody. So there's just basic information about the device. You can do native tools like ipconfig, nslookup, so forth and so on. We've already done get UIDs, which tell you the current user, their permission level, and things like that. PWD, print working directory. This is really important for when you want to start doing things within the file system itself. So print working directory, where am I currently at? Where is this terminal located in? So I can figure out where I can go and how I need to get there. So I'm currently in system 32, which is great. Which is, well, that's really it. It's great. Otherwise, ls list. And then this is the content of system 32. Right? So at this point, if there's anything like a text file, a document, or an executable, you can just run them directly from here because now you have a list of the contents of this folder, as well as their names and their file types. So you can just run things. You can open the content of files. What this one was going to have have us actually do is this was supposed to be in the downloads folder because this is where the exploit was initially found in the downloads folder. But since we did a privilege escalation to a system account, we're now in system 32. But yeah, the exercise otherwise is pretty much, is going to be similar, right? This would have us look at a text file called secrets.txt and use basic Windows commands to otherwise look at the content of a file. That is cat secret.txt. There's the content of it. Oh, my credit card number is this because, sometimes people put sensitive stuff in text files on their desktop, like passwords. What we can move to, make ourselves as efficient as possible with time, right, there we go. So keylogger, there's a keylogger utility that is also built into Meterpreter because, well, Meterpreter knows what it is and knows what it was designed for. So the keylogger utility in Meterpreter is key scan start. That's it. And now it's just running a sniffer, something that runs passively and just listens for something. So go to Windows 11. actually open up secrets.txt and say, just type anything, right? Never mind, my real number is 129, blah, 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 right? And then just a couple of other inputs, whatever. So save, sure, why not? Exit out, cool. Something has been typed, go back. So things that operate in sniffer mode, they typically won't show you things as typed because that can get, well, frankly, obnoxious. And also you're going to probably be doing other things while a key scanner is running in the background, right? As an attacker, you want to multitask. You don't necessarily want to just look at the keylogger and wait for it. So yeah, I would initiate that by a key score on a key scan, otherwise dumping captured keystrokes, and then it would otherwise put them out on the on the display, right? Something of this nature. Again, because I'm modifying the way this lab works to save us some time for things like that. Another nice thing I very much appreciate about EC Council's labs is the if you are ever going through the instructions, they actually give you these screenshot feedbacks for the kind of thing that you're expecting. But this is what it would look like. One of the reasons that could explain is actually a good demonstration, even though mine didn't seem to capture anything. It's still a good demonstration nonetheless because it does also illustrate the nuance that attackers actually need to do. They actually need to perform in that it can come down to very specific context of how these tools are ran. The fact that I ran a key scanner in a low part of the file system that the text file isn't, or just a different user account, or some kind of different context, may cause a otherwise simple utility to possibly give you inaccurate results or less results or just nothing at all. So that kind of stuff matters. Again, obviously, I'm not getting a result, even though you saw me directly go into that account, type something in, so forth and so on. So there's that. Right? Or the connection may be established with a different user. Sometimes attackers lose track of what sessions they're connected to. So, that kind of thing can happen. But anyway, other commands we could do, for example, is let's say the attacker is concerned with running otherwise obvious activities while a user is actively using the device. Idle time. This user has been idle for 17 minutes, an hour, 3 hours. Good way to determine, if you can do certain more overt activities. Sure. Accessing the device to do some more post exploitation. Let's see, dir versus AH and enter. This shows us directories with hidden attributes, which we're not going to see too much in System 32 given where we are, but this shows us more information about, the hard drive itself, like the space and capacity open on the hard drive. If this was other file locations like downloads, you'd see certain other hidden attributes of the content in there. But yeah, essentially what you would see, just additional content like hidden files and folders, which would make that very useful as a reconnaissance tool. Specifically, hidden files and folders is really useful. It's something you get out of there. This one in particular is what if I want to look at not just files and folders, because I can map that out very, eventually using these simple commands. I can also look at what background services are running on this device by, well, using a command that does specifically that. State, I just want to see all of them because I just want as much information about this device as possible. And there's all running services and a bit of information about each of them, right? Especially now taking this, if there are known services that can be exploited and have known vulnerabilities, I can use this and follow up with that. I'm identifying further targets now that I'm on this device. An important part of establishing a foothold, these post exploitation activities is what are some methods that I have available to me now that can help me establish a foothold, right? That's some of the reasons why we're doing some of that, right? What if I want to start trying to actually infiltrate stuff that I want to, let's say, bypass, or I want to infiltrate through some other kind of method? I can start scoping the firewall that may or may not be here and start changing that. Disable the firewall, modify the firewall, change, turn on and off security settings and things of that nature to open this up for other things. Good example of setting up backdoors is disable specific firewall rules that you can use to specifically get in, or create a firewall rule that allows specific activities that you want to perform as well is a good example of setting up a backdoor that is a gap in the firewall that hopefully only you are aware of. Right. And then this is just configuration information about the firewall, which again just allows you to understand what you're dealing with and things that you would want to turn on, turn off, so forth and so on. The next primary thing I wanted to show you is that WMIC tool, which is a Windows utility tool, which can do a whole hell of a lot to the Windows OS user accounts, things of that nature. And I'm going to show you a couple of them, right? So more specifically, right? Yeah. So information such as vendor information about about different packages, applications, the frameworks that this particular deployment is used of Windows is using, like Windows Groove MUI, what versions of the .NET framework for online services it is using, which has known vulnerabilities associated with them. Again, just a lot of really intricate additional reconnaissance for this device that you have, so you really get an idea of what you can and you want to do with it. Basic information about the CPU can be obtained through WMIC. Some really specific stuff that you would not necessarily see in something like Resource Manager or System Information. WMIC gets really deep in the Windows operating system to get this information. So also it helps to have something like system level permissions, which we already did, to do stuff like this. Here's stuff we found through another method, right? The user accounts, not their hashes, but just what user accounts are on here. We would get the credentials through accessing the SAM database, which we did with a dump utility. Right. And then WMIC OS, where primary equals, and there are much easier ways to do what this one's doing, but it's just showing diversity if nothing else, forces the device to restart. It forces the device to restart, assuming that, well, we type it incorrectly. WSOS where primary equals true reboot would attempt to reboot the given device. Right? If it did, you would actually notice the interpreter session terminate. But like I said, because I'm changing a little bit the procedure here so that we get both of these in the time we got, the same reason the key scan start failed, we have a similar, problem with this command running properly. So again, it could be the context of what user account are we currently on versus what user account the target device is actually, the target is actually logged into and stuff like that, things of that nature, so forth and so on. So that actually ends up being the last thing I want to demonstrate from these two labs, being the main ones, and especially since someone, there you go, since somebody sounded like some of you are trying to jump out of here with your 2 hours. That's good. So anyway, yeah, no, I mean, if you got to jump out of here at this point, that ends up being the more important things I wanted to demonstrate and talk about. Frankly, the remediations are what they are. I'll go over them real quick, but otherwise, thank you for sitting in and all that good stuff. Again, these labs, both more slowly and more thoroughly, and the rest of the content they're in, all stuff that's actually covered in the course over the course of 5 days for us. But yeah, no, otherwise, in terms of, who to reach out to, training camp, trainingcamp.com for all the valid contact info. Anything you would need to ask me, they do take requests, and they will forward any questions to me if you wanted to reach out for any given reason. Anything about the certification, other certifications related and stuff like that, open to all of that if you ever wanted to reach out or anything. Otherwise, if I don't hear anything, I wish you the best. Those of you that want to stick around for the last little bit about the remediations, that doesn't take too long. That doesn't take too long to go over. So those of you sticking around, let me just transition real quick. But yeah, again, I'd say generally any lab that EC Council has here that shows Metasploit are very good illustrations of especially system hacking where we are, but also a bunch of activities associated with it. Like again, privilege escalation being a thing that you're almost always going to see done with Metasploit. You're very often going to see use of other tools within Metasploit, like Nmap, which is a network scanner utility, which is where we get a lot of this information in the first place. So their labs actually have a lot of really good demonstrative value, in my opinion. So this last little bit, again, for those sticking around for it, just common remediations. So what this all in all comes down to is, the concept of hardening. Hardening is reducing potential attack methods and means of given devices you wish to secure. Everything from, starting with, really, just get through this section in a good amount of time, patch management. This is any and all activities that are associated with keeping devices up to date and deploying updates in a way that is meaningful, efficient, and minimalizing disruption. Something I could very often say is one of, if not the most common reason for unintentional internal service interruptions is patches and updates. You update one system and it causes a bunch of other systems to stop working with it. That happens unfortunately frequently. So patch management is trying to figure out patch schedules, patch testing, and things like that to help minimize that kind of thing. But it kind of ends up being inevitable, which is why something called a backout plan or a rollback plan becomes necessary. But generally, I would say mitigation for pretty much any well-known vulnerability can come down to make sure things are updated and it takes care of them. What tends to actually define a vulnerability as well known is the fact that it has a patch usually available for it. Not always, but unless we're dealing with something called a legacy system. Yeah. So when it comes to the primary means that we covered in this short seminar, uh, most of the mitigation that's going to be helpful for especially password cracking and password retrieval that we saw is going to come down to preventing sniffing and basic password security concepts, which most people are aware of on paper, but are very poorly practiced in real life. Well, or at least in practicality. So sniffing, I'm mostly gonna focus on like key themes, like three themes for each category, because there's a lot of specific things in those themes, which again you would go into more detail in the actual full course. But for sniffing, use of encrypted protocols. Don't use HTTP, use HTTPS. What makes a packet unreadable is encryption. Use encrypted versions of packets. And make sure that the version of the protocol is the newest one, making the encryption more complex and adding additional mechanisms to make the communication harder to access. This goes right into data in transit protocols like SSL, TLS, SSH, and the like. Right? There's also suggestion for what are called obfuscation techniques of your network. Intentionally make your network more complex than it might necessarily need to be. Add more network segments, add more switches, add an additional router. These things, don't stop an attacker necessarily, but it makes their job harder and it makes them take more time to accomplish what otherwise might be more simplified tasks. And the last thing I'll generally sit here for sniffing, a lot of the activities that are follow-ups to sniffing are attackers changing or tricking your device into believing the wrong information. So setting static values is a common thing as well, right? Attackers would love you to believe that they are the router. So don't let the router's IP change. If the router's IP is static, then everyone knows that the router has to be this and it can't otherwise be modified. So things like that. Right? A lot more repeating values, frankly, here. Right? These lists coming from the same standards and good practice that EC Council will list to you in the actual course, right? But yeah, making sure that other than protocol versions, secure protocols versus non, any tools and applications you utilize have active support and have good, well, really user ratings when it comes down to it, because one facet of every form of compromise we really didn't even touch the tip of the iceberg with was application vulnerabilities, right? This is why it's so important not just to use tools and applications well, make sure you're actually getting a tool and application that has security features that meet your needs. After that, well, other than users being really bad at handling passwords, the other most common reason why most exploits and vulnerabilities exist is called common misconfigurations. You can have the most secure device or things on the planet, but if you don't use the settings correctly, you don't turn it on or implement it properly, then it can entirely not matter. Right? Common misconfigurations are common for a reason. So password cracking mitigation, again, a lot of things that most people are familiar with, like, use complexity, use a minimum length and stuff like that. So I have a few things to highlight here, like this guy, salting. Salting adds randomness to how password hashes are calculated. Because normally, when a password is hashed, when it's not using salt, a password will just get run through a hash algorithm as is and generate a hash output. When salting is enabled, the password gets combined with a random string of characters, and then the combination of those two things becomes a completely unique hash. This completely mitigates rainbow tables because rainbow tables rely on predictable and a pre-made list of hashes. My rainbow table will only work if I know that, the word password turns into 123 dog as its hash, if that randomizes, if that changes, then a rainbow table generally doesn't become effective. Which is why, again, the specific phrasing I would use, salting makes rainbow tables virtually, mitigates them virtually entirely, because rainbow tables rely on this predictability. Salting is literally adding randomness to password hashing as a mechanism. Also, a practical effect, you can see it down there. You can have three users with the same actual text password. All three, well, Alice and Cecil, they're telling you they have the same password that they use, but the hash that's in the database is completely different because their salts are different. Salts add randomness, thusly the result ends up being different and random. So, other than that, right, use information security audits. One thing that tends to be highlighted in pretty much any InfoSec exam in terms of mitigation of any sort is the importance of continuous monitoring and auditing. Never assume that a system is just good on its own merit. Check it, evaluate it. I'd say one of the most common activities that admins do against their own employee base is using these password crackers and skills against their own employee base. Use Cain Enable against your employees' passwords. Run one of these interpreter scripts and password dump utilities against your own admins to see if they're configuring their servers and their accounts correctly and things of that nature. So yeah, if you've ever heard of something called a phishing campaign, where I send a fake malicious email to my own employees that may contain, exploit.exe that I used in my labs, and see how many of them click that. In that case, your admin has 10 interpreter sessions and he sends a pop-up message to all of those machines saying, report to mandatory user training, right? That kind of thing. Sure, absolutely. Right? But yeah, disallow the use of the same password during a password change. Disallow password sharing is a pretty big one. Disallow the use of common dictionary phrases and words that you would find or associate with a word list and things like that. Possibly the consideration of a password manager, as opposed to expecting people to make their own complex passwords. The ones like in your browsers that say, would you like Google to create a random password that it remembers for you? Having its own advantages and disadvantages. One thing worth noting, setting the password policy to change it every 30 days is an outdated guideline. The current guideline actually is, as long as you create a significantly complex and long enough password, you only should have to change it if there is a report of confirmed compromise of it. That's actually the current NIST, the United States NIST specific standards and practice for password cycling. It is actually considered statistically and consistently a bad idea to implement password expiration. Unfortunately, password expiration guidelines is a guideline, meaning that it's not required. Because it's not required, companies will continue to be hard-headed about it, and they'll continue to use expiration because if it ain't broke, don't fix it. A tragic thing about InfoSec, computer security, that's not a good mindset to have when it comes to technology. How rapidly does technology evolve? And with it, how rapidly do attackers' techniques and approaches evolve, change, become more powerful? That is a dangerous mindset to have, and it's going to continue to prove itself because people are going to keep implementing password expiration. It's more important drastically. Having a password of longer, if 8 characters or more, vastly more important. 10 or more is excellent. And then with that, a minimum complexity of characters and special characters, you're pretty much good for a while. Haven't needed to change one or two of my passwords for more than a year because they're 15 characters long because I know memorization techniques, go figure, and they're too long to be brute forced in any capacity, and they're fine. The second, one of my security monitors say, "Oh, this password was associated with a breach," I change to another 15-character long password, and I don't need to think about it for more than a year. It's fine, right? So yeah, 8 characters or more is considered the minimum for brute force mitigation. That's based off of how brute force math kind of works out. 8 characters or more is considered, minimum. I'd say, frankly, 10 or more, what you are pretty much, set. You're golden, right? Anything greater than that, you run and you always run an increased risk of the human not remembering their password well. So that's why it kind of gives an upper limit, right? Another one that you may see very frequently: never store passwords or anything like an access key in the same places where they're going to be used, because single point of failure is a really good friend of any attacker that exists. This also includes things like code and applications. Something that developers sometimes have been caught doing is instead of having their application request connection every time or prove its identity every time, they instead hard code credentials in the application's code itself. This makes the application self-validating, which is more convenient, but it makes it self-validating if the attacker uses to leverage it. Also, if they manage to if they manage to reverse engineer the code and see it, they might just see the password in the code. It gives them a lot of means. Another big facet, probably literally the biggest, is social engineering and awareness training. The most fallible part of infosec security is always the human element. The fact that people keep clicking on weird and malicious emails, the fact that people keep getting tricked in similar ways. Awareness is making sure that people understand, at least in the broad and necessary sense, what these attacks are, how they look, and how they need to report and otherwise handle them, instead of just randomly clicking links from users that they can't verify, because that's why it keeps happening. Multi-factor is also quintessential. Multi-factor being generally one of the best, if not the best, form of access control and security that has been made, pretty much standard in even the public sector that has existed all in all, right? If you want to talk about a place where it is the most emphasized, where user error is the primary factor, it's mobile phones, right? Most modern mobile phone applications nowadays have multi-factor as an option, but people intentionally choose not to use it because it's slightly inconvenient. I can pretty much give you a pretty accurate predictor of where people aren't going to want to do something that makes them more secure. If you attach a security check to a thing, to a process that people have to do many times in a day, or even multiple times over the course of an hour, people are going to fight tooth and nail against it. Multi-factor authentication added an extra 30 seconds to somebody's login for something they have to do multiple times a day, logging in. So people hate it. They'll act like it's the worst thing that ever happened. And then those are the same people that get upset when their password or account gets accessed. You kind of did it to yourself. It's actually a known statistic. 90, somewhere between 90 and 95% of compromises that happen involving smartphones are the user's fault. That is a known statistic, and it might even be higher, like 98 in some cases. So, lastly, again, the role of continuous monitoring. Threat hunting actually being a really important emphasis of, in really focusing on why continuous monitoring is important, is that so many of these attacks and approaches are designed to be subtle. I mean, even though they were very staged, they were quick, and they were very, to demonstration. A lot of things I did in my short lab exercises even were designed to be, somewhat stealthy, right? The fact that you looked at the victim's machine and you didn't see a terminal open. The fact that the only thing you would really notice is if you saw files suddenly show up in the download folder, but otherwise nothing too overt, nothing amazingly obvious. So threat hunting is operating under this assumed breach mindset. Always assume something is attempting to happen, because not most attacks will never give you obvious symptoms until the worst has already happened. This requires twofold: a centralized and constant understanding of your own system. There are attacks that you will never detect if you don't know what normal is in your own environment. And two, actual threat intelligence. This is what you know about how attackers do what they do and the attacks that they learn. The CEH focuses on the latter. The CEH, Certified Ethical Hacker, focuses on learning and understanding the tools, techniques, and approaches from the offensive side of things. Offensive security is threat intelligence, where what I call situational intelligence, what you know about your system and how it operates, the baselines of your network, that's situational awareness, also called operational intelligence. You get that from intrusion prevention devices, intrusion detection devices. SIEM platforms are big for this. Splunk and SolarWinds, if you're aware of those as a specific example. Network visibility is their job. Not just, here's a bad thing that's happening, but what's been going on in my network, just so I establish that as a mindset. Both are necessary to actually accurately and, meaningfully detect even more subtle, less obvious means of compromise and intrusion. So, went over that 2 hour just a little bit, just a little bit, considering the break and the slight delay of start to make sure people were in here that needed. I suppose that's what I got for this quick little discussion we had. So yeah, um, if people got somewhere to be, I mean that's all I got. And I thank you for your time, your attention, and your attendance. But otherwise, if there are any other general questions, I got got a little bit of time for an open floor. If that's something that if you had anything on your mind in general, again about the class and anything of that nature, or the content, open Q&A more or less. But short of that, you're good to go if you have something else you need to do, dinner or whatnot, right? Because if there otherwise isn't anything directly, again for me or for whatever what's going on here, let me actually make sure that the because sometimes Zoom likes to mute everybody if you're trying to say something, but yeah, no, otherwise, yeah, that's generally is again this quick little seminar look at a focus look at module 6 of 20 in the CEH certification. If nothing else, I'll at least talk about this real quick. But yeah, the full certified ethical hacking certification goes over of course 5 days, right? About a 9 to 5, I would expect most days, maybe a little bit over. If you really want to fit in more lab activities, it goes a little longer. But it goes over the course of 20 domains, which covers a lot more, other topics. Obviously, we go over, pretty much head to toe everything about reconnaissance, the actual way to get information in order to work our way to where we were with system hacking, and then following that up with a lot of either very specific compromise, like mobile device exploitation, very briefly, web application exploitation, very briefly, and then a lot of other concepts focusing around the premise of a penetration test, which is a offensive security method where you hire somebody to use these techniques to evaluate your system. And that generally, again, is the overall premise of the CEH. And being a 5 day course, again, we talk about these concepts in a bit, again, I don't want to say watered down, just spaced out a bit more with a little bit more time because we have more than 2 hours. But yeah, there's at least that, if nothing else. But yeah, otherwise, if again, if you had nothing else in particular for me, I hope you enjoyed your time. I hope you enjoy your night and your weekend, wherever you may be and wherever you may go. Again, if if I end up seeing you on the other side in an actual exam, I'd be glad to have you. But otherwise, again, I hope you take care of yourself if I do not. Just hanging around for a minute or two just in case something comes up. That's all. All right. I'm gonna say that's probably enough awkward increments of silence that I suppose I'll wrap it up formally here. So yeah, no, again, those of you that may, I don't know, if you're driving or moving or just stepped away for whatever moment, again, still thank you for your time. Thank you for listening. And again, anything that you need to otherwise, ask training camp about the classes and stuff like that. I'm pretty sure you already know where to go. Otherwise, again, my name is Marcus Clark. I work for them very frequently for this test and many others. Again, if I see you, I'll be glad to have you. But otherwise, you take care of yourself out there and all that.